In this video, we're going to talk about inequalities and the different ways it can be represented. When we talk about inequalities, there are three ways it can be represented. One, it could be represented using set notations. Set notations are when you use the inequalities. Less than, equal to, greater than, equal to. Or we can use interval notations. Interval notations when we use parentheses, brackets, or a combination of parentheses and brackets. And the last one is graphical. When we draw a line, it could be either an open circle or a closed circle. And we can either shade between there or opposite directions. All right, so, for example, if I gave you this set, what numbers would that represent? Parentheses means it cannot be included. So the numbers at the endpoints, whatever has parentheses, so in other words, it tells me that 2 can't be included and 5. So it means everything in between, which is just 3 and 4. Brackets are just the opposite. That means those endpoints can be included. Since 2 has a bracket and 5 has a bracket, that means my answers would include the 2 and 5. Let's say we had these. What this one says, this is parentheses, I cannot use 2, but I can use 5. So it's 3, 4, 5. Bracket means I can use a 2. Parentheses, I cannot use the 5. So it goes 2, 3, 4. So that's what those mean. Now graphically, here's 2 and 5. That's 2 and 5. They're both open because they're parentheses. If they're both brackets, then it's solid dots. If one's open, one's closed, that one's open, that one's closed. This one's open, that one's closed. And finally, that one's included, so it's closed, and that one's open. So my answer is 3 and 4. 2, 3, 4, 5. 3, 4, 5. 2, 3, 4, and stop right before 5. So that's what those mean. Let's look at all possibilities here. All right, this is the first one. Let's start with the graphic. It's a solid dot, and I'm going to shade this way. These are my x's. It's going from a to positive infinity. So the set notation, I look at all three of these. I start off with a, go through x, and I end at infinity. I'll always use that direction. Now the only thing, since that's a solid dot, I put a line underneath it. Infinity you can never get to, so it's always an inequality. But this is redundant. If I say x is bigger than a, it's going to go on for infinity. So I don't need that part. So I have x is less than or equal to x. A is less than or equal to x. But what we normally want is x to be on the left. So we can flip the equation. But be very careful. It has to still point to the same. So this one's pointing to A. So it has to point to A. So whenever x is on the left-hand side, the direction of the arrow tells me the side I'm shading. That's set notation. Interval notation, I only look at the endpoints. I start at A, end at infinity. So I put the beginning and the end. That's a solid, so it's a bracket. I never can get to infinity, so it's always a parenthesis. All right, let's look at the next one. So this one's going to the left, to negative infinity. All right, so I'm starting, remember, always read left to right. Negative infinity, xa. So it goes negative infinity is less than x is less than a. That's a solid dot, so I can include a. That's redundant, so I don't need that. So what I have here is x is less than equal to a. Remember, it's x is on the left-hand side, arrow is pointing to the left. That's the side I'm shading. Again, now for the interval, look at the extreme endpoints. Negative infinity all the way to a. Infinity is always a parenthesis. Since that's a solid dot, it's a bracket. This one starts at a, and all my x's go to infinity. So I start at a, x, infinity. And I have inequalities. But a is open, so I can't put a line underneath it. And I can never get to infinity. Again, that part's redundant. So I have a is less than x. I can flip them, x, but it has to point towards a. So a is less than x is the same thing as x is greater than a. And it's pointing to the right, so that's the side I'm shading. Look at the endpoints. I start at a and go to positive infinity. A is open, so I can't use it, and I can never use infinity. Likewise, now I have these. So these are all my x's. So for the set notation, I write all three. So I have negative infinity, x, a. Less than. I can never use infinity, so it's always going to say less than. Open, so I can't put a line. That's redundant. So my answer is x is less than a. Again, it's shaded to the left of a. That's where it's going. So the integral notation, look at the end points of my shaded region. Start at negative infinity and at a. Infinity is always open and parenthesis. So a is open, so that's a parenthesis. So those are all the infinite ones because it goes on to infinity from one point. Let's look at the next four. These are called the finite ones. I'm looking at between two endpoints. Remember, wherever I shade, That's my x. So I start with A, I go through x, and I eventually get to B. Now, since it's a solid dot on A, put it line. It's a solid dot on B, put it line. And there you go. For interval notation, go to the endpoints. They're both solid, so it's bracket, bracket. Between these two. Remember, wherever I shade is my x's, so I have A, X, B. A is shaded, so I can put a line underneath the A. B is open, so there. There's that graph. That's that set notation. Interval is only the endpoint. A, comma, B. A is solid, so I can use it. B is open. You notice, since A has a line it's equal to, so it's box. Alright, so my x's are between A and B. A, X, B. A is open, so no line. B is closed, so it gets a line. Interval, I only look at the endpoints, A and B. A is open, B is closed, and has that line. So between A and B. A, X, B, less than. And they're both open, so there's no line underneath it. Just think about it. This one says A is less than B. Less than is left. X is less than B. A is less than X. X is less than B. Look at our endpoints. A, B. I can't use either of them. So there. Now the infinite enclosed, which means that the graphs go in opposite directions. Remember, these are our x's. We have two sets of solutions here. For the set notation, I look at the negative infinity is less than x is less than a. But a is solid, so I get less than equal to. And then b, x. So b is less than x is less than positive infinity, and I can include b. But think what this means. If I'm thinking of an answer, the answer could be here, or it could be here. So that's why we put the word or. Remember, these are redundant as of above. So, in other words, x could be less than or equal to a, or x and b. It's got a point to b. X can be greater than or equal to b. Yeah. X can be less than a, or x could be greater than b. Now the interval notation. We have two sets of intervals. We can go from negative infinity to a. We can go from b to positive infinity. And remember, infinities are always parentheses. These are both solid. So here we have, when we do interval, we use the U for union. It means the same thing as or, but it looks more mathematical. Okay, the next one. Less than a and greater. These are our x's when we deal with set notations. So we're going from negative infinity, less than x, less than a. A is solid, so it's a line underneath it. Or b is less than x is less than infinity. Get rid of the infinity parts. So x is less than equal to a, or it's got to point to b. X is greater than b. For the interval, look at only the endpoints. So we have from negative infinity to a, and a is solid, so it's a bracket. It's got a line underneath it. Union, b is open, and so is infinity. So left of a, right of b, we have negative infinity is less than x is less than a, it's open. Or b is less than x is less than infinity, but b is solid. Get rid of the infinity parts. So x is less than a, or x, it's got to point to the b, is greater than or equal to b. Yeah, so if you look at the picture, x is greater than b, or it could be equal to it. The endpoints, negative infinity to a, and a is open, so it's parenthesis. Union b, comma, infinity. B is solid, so it's a box. And likewise the last one. These are the x's. So I go from negative infinity is less than x is less than a, or b is less than x is less than infinity. Negative infinity, x a, b x infinity. Get rid of the infinity parts. X is less than a, or got point. X is greater than b. And they're both open. So negative infinity to a, open, unioned with open b, they're both open. Now, if you just have a dot would be represented as that. You can include a. That's all you can do. Or x is between a and a. And if I can't use a, that means x is less than a, or x is greater than a. It just cannot equal a. So this one is everything else. This one is from negative infinity to positive infinity. Negative infinity to positive infinity. This one is just x. Or we write, it's actually looks like this, it's a realtor symbol. It means all real numbers. If you need to watch this again, there's a link down here. You can watch it. All right, go ahead and do the homework, and good luck.